for that day, so I could do the overnight. And then took a nap the next day. I was all caught up by the end of the day. So let me get started. It's 7:31 on the 2nd. For those of you who don't know me, my name is Mark Menerich. I'm the president of the astronomy section of the Rochester Academy of Science. Welcome, everyone, to our April virtual meeting. I want to thank Dave Pesch and his company Expudo for donating this service. And this allows us to have almost as many people as we can accommodate at our meetings. And this is I said almost about any amount of people that we want at our meetings. So it's been unlimited. So it really has been nice for having this service and at no cost to us. So if it gets noisy, you can mute yourself, or I may mute you if you have a hot mic or something. I'll mute you. Don't be hurt by it. You can always unmute yourself at any point in time. So feel free to do that if you want to talk to the group. You can always chat. There's a little chat bar that's next to the number of users, the people that are using, in between the users and the presentation itself, and you can type in the chat box any comments, or do you want to chat me directly for something, or anybody else directly for something, you can do that as well. And it's always best to listen and talk with a headset if you have one. It cuts out a lot of background noise, except on my computer. My computer's noisy right now. All right, so here's our agenda. First, we'll do a welcome. I'll have some announcement. We have an Astro challenge. If you read the newsletter, you read the Astro challenge, but I'll read it again to you when we do that. So if you have read the Astro challenge, I hope you've thought about it a little bit, and we'll try to address the challenge. And hopefully, Dr. Richmond is on. I don't see him here. It's his challenge. We shall see. And then our feature talk by none other than Larry McHenry, who's joined us for another meeting. So welcome, Larry. Glad to have you. And amongst Larry's repertoire, we chose Planetary Nebula from Messier to Abell, what they are, and how to observe them. And before I go farther, let me suggest this. If you have a computer or a ISP with low bandwidth, one of the things you can do if these videos are slowing down your service is to click on those 3 ellipses all the way in the upper right of this presentation area, the options. If you drop those down, you'll see a button for settings. And if you click on that, you'll see application and data savings. If you click on data savings, to the right of that, you'll see enable webcams. You can turn webcams off. And what that will do is turn off all the webcams coming into you so that you can save bandwidth. If you have a low bandwidth service, that'll save you some bandwidth coming in, so you're not losing things on the presentation tonight. All right, with that, is there anybody, this is the first time they've ever been to a astronomy section meeting that's on tonight? I see a lot of familiar names, so doesn't look like there's anybody brand new here. Oh, Am's here. Are you from RIT? Yes. So Am sent me a note. I think he's working with Marty and his team on the radio telescope project, or Radio Joe project, and he wanted to get a link to the meeting. So welcome. Glad you joined us. How about observing? Did anybody get these observing done lately? I saw we've had some images, so there had to be some observing that happened. I just took a couple images that Peter didn't already print in the newsletter. One from Bill Hugh from March 22nd of the Medusa Nebula. That was kind of nice that he did. And then the image to the right is an image that I took. It's about a 60-second image of M81 that I did during the Messier marathon. So for 60 seconds, that's a pretty nice image. No flats, no bias, no dark frame, just a quick lucky steady shot that came through on M81. That's the beauty of the of using that hyperstar, a really fast imaging, so I can take a nice image like that. So it came out great. Any other? Nobody else did a Messier marathon. Is Hank here? Hank was here. He doesn't have his microphone on, but Hank was out there for the Messier marathon. So we both bagged it at the same time. Hank's typing. Hank said he got 38 Messiers. That's great. And he did it the honest way. I probably got 70, but I had a lot of help with the scope going bing, 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 hitting them all. So it was fun. It really was a nice night. Which was my next. So did anybody else do the Messier marathon or attempt it? Bill Schlein in your tent on your driveway. Did you give it a shot?
I did a Messier microthon. I got one M99, took an image of that.
There you go.
I sent it out.
We did see that. And Hank doesn't do go-to. It's true. That's true. So I'll move on. So I sent a number of U of R notices out in the last week or so. Anybody catch any of the talks? Some of those talks that the University of Rochester had for the seminar, and as they come in, I'll send more out. There's more coming up in the next week or so.
Have they started to make any of these available afterwards? It would, it's hard to.
I have one. Yeah, that's a great question, Jim. I did. I asked the secretary of the physics and astronomy office if I could get them, and I have to appeal to the speaker to release each of the videos. So they're not just making them willy-nilly available, but I do have Eric Mamachek's available, the NASA Exoplanet Exploration Program, which he's in charge of over at NASA. So the link is here. I think I also send it out. If you need it again, I'll make a note to myself right now to send that out after this meeting.
One of the issues we had, because some of us have been going to these things for like 15 or 20 years in person, but one of the issues they had was that they're often talking about unpublished projects at this point, and
yes,
by making a video and putting it online, it might violate rules of disclosing unpublished information before it's been refereed.
You may be right. And to answer Michael's question, yes, they also include the RIT ones as well. Yes. Pardon me while I write a note. Okay. But as they come through, I will push them out to you guys so that so if you're interested in them, you can catch them. A lot of these are in the afternoon or evening. There's some really nice talks. There's some very deep talks, for lack of a better phrase, but I'll let you guys know what they are.
Mark, you might want to offer to archive them in a way that doesn't make them public. That might, solve an awful lot of it. Put it behind the club firewall or something.
Or if I'm just sharing a link with our group, I don't know if that's a public notification. I'll find out from Yvette over at the Physics and Astronomy if I could do that. Joel Kastner had a nice talk last week. That was pretty good too. He moderated Laura Newberg's talk. That was really interesting. Old cosmology structure and mapping the cosmic microwave background. That was a fascinating talk. That's one of the four that are up there, Eric Ramajek's, and one of they're all kind of interesting talks. We actually did already see Ranga Diaz's talk on superconductivity. That was one of our talks. That was our talk in January, I think. If you need more information on that, let me know. Shoot me a note or shoot me an email or something. I'll get what I can of those. All right, so we just had the Messier Marathon 1, and if you go to our YouTube page, Astronomy section, Rochester Academy of Science, you'll see that. And I have recorded. I haven't edited Messier Marathon Part 2, but I will edit that this week, and we'll have a party right here at this site, this link, everything, next Friday. Same link as tonight, same time as tonight, 7:30. Won't be as long as the other one. Last one was about 2 hours, but we had a good time. This will only be about an hour for the, I think, for the Part 2 of the Messier Marathon. We'll see how far we get all the way into the morning, Part 2. We have a board of directors meeting next Wednesday. This is open to any members. If you want to attend, let me know that you'd like to attend. I'll send you a link to that meeting. There's a link and a password to go to that meeting. Glad to have any member that wants to go come to that meeting on Wednesday. At those meetings, we decide what we're going to be talking about at the meetings. We plan events. We also plan how we're going to handle outreach, which hopefully we're going to get back underway soon. And as we learn more on how we can gather, some of those restrictions sound like they're coming off soon. So we'll see what we can do to accommodate more in-person type of activities. Certainly, we do some right now. We do open houses, and the open house is next Saturday. It's also observing that night, and we're observing protocols, the same protocols we've had in place since last June or July. I'll go through those in a second. So if you can read all this down below there, really what it amounts to is we want everyone to sign in, make sure that we know that you're there. That way, if we have to trace contacts, we know who's been there. If there's an active case of coronavirus that gets spread, we ensure 6-foot distancing. And you need to wear face masks, especially if it's going to be a lot of people there. Make sure you're wearing face masks, because people will get less than 6 feet apart. The building is under 50% of capacity, which would mean it's 30 people instead of the 60 people that would be normally allowed in there. The bathrooms will be cleaned and operable. Is Roger on? Roger, do we expect that we might be able to open the bathroom up for next Saturday? Give him a chance to turn it off.
Hi. I've been kind of keeping an eye on the weather, and it's supposed to be about 18 degrees tonight, so I'm glad I haven't opened it up yet. I'm going to take a look at the weather. If it looks like it's going to stay for the most part above freezing, then we probably can do that. What I want to avoid is having to open it up and then having to shut it back down again if we're going to get another cold snap. So, we got a week to worry about it, or 5 or 6 days anyway. I just take a look at the forecast and see what it looks like.
All right, we'll plan it. We'll figure it out when it comes in. There'll still be a bathroom available. Not like you won't be able to have a bathroom available.
Yeah, that's been available all winter.
Yep.
The downstairs has been available all winter.
Yep. And this protocol for using the bathroom is making sure that you wipe the faucet and handles, and then you dispose of the wipes. They're all available right there in the sink, and you dispose them right in the garbage. Wash your hands. And if you're there at night, use red lights. And so we'll also do that night on the 10th. If you didn't or weren't able to do the Messier Marathon last month, now you're going to miss a few because the handful that are near the horizon in March will be certainly at or below the horizon in April, just because of the way the sun tracks. And so you won't be able to catch those early ones. But if it's a nice night next weekend, come on out, bring a scope, or use a scope that's on the hill. I've got the targeting tools that I sent, and I'll send them again as a reminder if you want to do a Messier Marathon next weekend. And if you want to do it virtually, the night before we'll be finishing one virtually the night before on Friday night. So, and no need to stay all night. If you want to just come for an hour or two, come on out. If it's a clear night, it's always worthwhile coming out with other fellow astronomers to do a little observing. Hank will be there. I know Hank will be there. Upcoming events. So in our May meeting, we have an interesting speaker, Donald Brighty, who has a PhD in theoretical physics out of Syracuse University. And he's done a lot of, it's theoretical physics. And so that's stuff like wormholes and black holes and time travel, space travel. There's some really interesting things that he's done some work on. And it's, trying to, within the constraints of normal and exotic physics, figure out how things work. And so the working title right now of his talk in May is Wormholes and Time Machines, and I'll have a more in-depth bio for him that I'll send out during the week before. But he's really an interesting guy, so we'll look forward to that talk in May. So that's Friday, May 7th, right here at 7:30. And we'll have Donald Brighty of Syracuse University talking about that. All right, I think I said this last time, but I'll keep it up here, is save the dates. We're planning an in-person Rochester Fest, August 27th and 28th. We're celebrating the 30th anniversary of the Ferris Center. That little asterisk is because it's really 31. We would have done this last year, but we weren't able to, so we're going to do it this year to celebrate the 30 years of the Ferris Center. And we have a very special speaker in Alex Filipenko, who's going to talk to us that evening. Very engaging guy. And everybody's familiar with him. You've seen him talk. Flipper, yeah. Michael, was he your PhD? What do you call it? PhD coach? You were his second PhD student. That's awesome. So one of our own was his second PhD student. That's awesome. Very cool. And the teaching style is kind of similar. I think I know where that comes from now. You have heard that, and it's true. It's true, and it's very engaging. We appreciate it. All right, so we had an Astro challenge. An Astro quiz was in the newsletter. What I'll do is I'll read it to you, and then let's have a little discussion on it. And I put this eclipse up there. This is an eclipse image that Peter Blackwood took near Charleston, South Carolina. And we asked Dr. Richmond to give us an Astro challenge this month. And so here it is. This is a lot, very tight reading, so I'll read it. So the question is, where can you stand to see a solar eclipse? Humans on Earth are lucky. The Earth's moon has just the right size and just the right distance that when it happens to move in front of the sun during its orbit, it covers the photosphere of the sun completely and leaves the pretty colors and prominences of the chromosphere visible to us as well. At least during some eclipses. This is when we see this beautiful phenomenon. We are not only living in the right place, but at the right time. The moon is slowly but inexorably receding from the Earth, making it appear smaller and smaller with each passing millennium. In just another 750 million years or so, and that's really short astronomical time, the moon's disk will appear to shrink so much that it will never ever cover the sun again. Sigh. So just how lucky are we? Well, are there any other places in the solar system where humans might stand on solid ground, or perhaps on a floating platform hanging from balloons, and see some other body eclipse the sun? To qualify, the occulting body must be very nearly the same size as the sun. Let's say that if the body and the sun are within 3% of each other's diameter, that will count as a total eclipse. Can you find such a place? Or is the Earth unique? It's okay if visiting the location might prove unwise or harmful to the viewer's health. As long as he can see the eclipse with his own eyes before he dies, our tourist will be a happy man. So, has anybody given some thought to this? Says this is a very Richmond problem. Yep. You know who wrote it?
I tried to run I was going to say I tried to run some numbers, and I didn't have a chance to go through as many things as I wanted to, but I just looked at Jupiter and the 4 large Galilean moons, and if I did the numbers right, the moons are too big with respect to the sun, the 4 Galilean moons. Now, if I did it right, if I screwed up, I'm wrong. But that's the result that I got. I didn't have a chance to go through the major moons of Saturn.
Yeah, so Michael says you're correct. Or are you saying that Dave Bishop is correct? I'll give him a chance to type. Dave Bishop guessed Pluto and Charon.
Oh, really? That's an interesting combination.
Yeah. He said Galilean moons seen from Jupiter are too big. Yes. So you were right. Not Pluto and Charon. Well, how many other planets have moons? You've got Saturn. Well, there's other moons of Jupiter. So there's got to be some smaller moons of Jupiter, perhaps.
They're way smaller.
Yeah, but it's the proportion, right? Because the sun's going to be smaller too.
Well, the sun's going to be the same size as Jupiter, no matter which moon you're looking at.
Yeah. Relatively speaking, but I'm saying if you're out at Pluto, it's the relative size, the angular diameter of the two of them. Yes.
Yeah.
Correct.
Right, but the sun's going to be way smaller. So again.
Bob Easterly says sun is smaller with Mars. So, you mean Deimos and Phobos? Or just Phobos, Bob?
I think those moons are too small also.
Phobos is too small. We've actually got a shot from one of the rovers of Phobos.
Yeah, Phobos
and
is
it's
quite
an annular eclipse.
Yeah.
Michael, if you want to give me the URL, I'll take us there. All right, so I'm going to share Michael's response here. Let me do that. All right, so this is, let me see if I can make this a little bigger here. Give me a moment.
There's a link at the top that says this is a special place, or is it? Click on that.
Okay.
Now you want to make your screen smaller, believe it or not. Yeah. So if you scroll over to the right, you'll see what we want to reproduce. There's the sun as seen from the Earth, and the moon as seen from the Earth. And there's the beautiful, just barely covering the sun eclipse that we want to reproduce as seen from some other solid body. Several people already mentioned Mars. If you scroll down a bit, you'll see, down a bit, you'll see some, there we go. So that's what would happen if Phobos were to go in front of the sun as seen from Mars, as Dave Bishop and others said. It's not quite big enough to cover the entire disk. And scroll down a tad and you'll see real pictures, as Dave Bishop mentioned. There's real pictures taken by Mars rovers of a solar eclipse, kind of, as seen from Mars. So, good guess, not right.
Are other people seeing the screen? I'm not seeing Mark's screen.
It should be on the presentation.
I'm not seeing anything. I'm seeing spinning arrows.
Oh boy.
So
I'm seeing
what I
Mark's
would-
screen just fine. It's a bandwidth
right.
problem.
Okay.
So Dan, why don't you turn off the videos? Go to the options, settings, and data savings. Turn off the videos, and you should be able to see it.
Okay.
So if you scroll down a bit more, you'll see that actually one of Jupiter's moons almost works. So seen from Jupiter, you can see the sun is smaller. Amalthea, the fifth moon of Jupiter to be discovered. Does anyone know the name of the famous astronomer who was the first Earth person to see Amalthea? He's found it visually by looking through a telescope with his eye. Any ideas? He was using the a really big telescope, the Yerkes 40-inch telescope.
That's a big hint, and I should know this.
Yes, you should.
Mr. Bernard?
It would be Mr. Barnard. That's right, E.E. Barnard. Anyway, so Amalthea almost makes it, but not quite. If you scroll down a bit more, you'll come, I think, to another couple of things that don't quite work. But I checked, and I couldn't find any combinations of someone standing on a planet or floating in the cloud tops of a planet, looking at the sun and seeing an eclipse. I could not find any if I just used planets as the standing place. But if I stood on one moon and I looked past another moon, it turns out, can you scroll up just a bit to the previous diagram there? You can see, yeah, that one. You could see that as the moons of Jupiter go around Jupiter, they pass by each other at various distances. And so you get a large range of possibilities for each pair of moons in one particular planetary system, either moons of Jupiter eclipsing moons of Jupiter or moons of Saturn eclipsing moons of Saturn. And there are several combinations that will work. And if you just scroll down, you see several of the possibilities there. So let's see, that's Callisto from Io, and then you can get Callisto from Europa, and then Callisto from Ganymede. And so mutual events between those moons will give you good eclipses. Of course, standing on the surface of any one of the Galilean satellites will probably not be a very healthy thing to do, especially the innermost ones, because Jupiter's radiation belts are pretty darn strong. So I think there may be one combination of Saturnian moons. Yeah, yep. So I think it was Titan and somebody, I'm not sure. Oh, it's Tethys and Mimas. How about that? Anyway, if you want, this is sort of cheating, right? Because it's a moon and a moon. And not only that, but the moons move it around each other at different distances, so you get a very wide range of possibilities. But if you're willing to accept moon eclipsing moon, then there are quite a few objects in the solar system that can give you a nice solar eclipse. So that's the story. And those of you who want to can go to the URL that I placed into the public chat, and you can read through not only my notes about this, but also some notes I made about solar eclipses as seen from Earth. I wrote all this up back before the 2017 eclipse in Nashville.
Wow, there's quite a few.
Yeah. So any quick questions that people want to ask?
How long do these eclipses of the moons last?
So that's a very good question, and I don't know the answer off the top of my head. I would guess that they last, I don't know. I'd guess they last for quite a bit less time than our typical moon-sun eclipses. But I don't know.
Tony asks, what kind of frequency do the moon eclipsing events have? Are there sorrow cycles?
These are also very good questions. So if it's possible at one point in their orbits for it to work, then the periods of the Galilean moons are between 1 or 2 days and about 8 or 9 days. I think they're going to be pretty frequent mutual events. Well, actually, some of you observers will know this. I'm sure some of you have been looking at the moons of Jupiter when one of them goes into the shadow of Jupiter and disappears, right? Well, if you're really on top of things, you can watch one of the moons go into the shadow of the other moon and disappear like that. And that's what's happening in these eclipse events.
Yeah. It's interesting because they're moving typically in the same direction. So even if they're moving quickly, because they're both moving together, it could really elongate the time of the eclipse longer than what we typically see. Interesting. All right. Yeah, so the link is there, and I'll put that in the notes about the meeting. So, awesome. Thanks, Michael. Appreciate that. That was a really interesting challenge. All right, which brings us to our feature presentation, and I will turn this over to Larry McHenry. Let me get you squared away here, Larry.
All right.
All right. You are now the presenter.
So while Mark's getting this set up, just real quickly, I posted earlier in the chat a link to my handout that I normally give out when we do these things at Cherry Springs, mainly because at Cherry Springs, the way they position the projector, sometimes you can't really make out what's on the screen, but I don't think we'll have that problem tonight. So let me see here, Mark. I see that. Let me click on the plus button, right?
You wanted to share an application window, so you want to
Share
do the
there.
other one.
Share an application window. Okay.
So you want to use the bottom right button.
Bottom right. All right. Well, first off, I see it. Let me get the presentation up and running. And switch back to Big Blue. And hopefully everybody's seeing my pretty blue screen here. So, all right, we good to go?
We're good to go.
All right, perfect. Well, good evening, everyone. Again, my name is Larry McHenry. I'm from the Pittsburgh area in Western Pennsylvania. I'm a member of the Kiski Astronomers and the Oil Region Astronomical Society. Tonight, we're going to talk about planetary nebula. So planetary nebula, when I hear that phrase, I think of a specific type of deep sky object, a type of object that's always interesting and fun to observe or image. They also bring to mind their descriptions. Here we go. Colorful ephemeral ghost, luminescent wispy shells, little crystal ball gems up in the night sky, delighting amateur astronomers using small or large telescopes. They run from large, easily located extended disks showing great detail to tiny, almost point-like, challenging to find. Interstellar graveyards, giving up the secrets of stellar evolution while spreading their wealth of star-forged elements across space to be swept up by gravity to enrich the next cycle of starbirth. So tonight, I would like to bring these ethereal objects down to Earth by discussing what they are, why we call them that, some of the people, both historical and modern, behind these objects, and how to go about observing them. Hopefully, when we're done, some of the mystery around these objects will have been lifted, and you'll find them as interesting to hunt as I do. So just a high-level outline of what we're going to talk about tonight. Of course, what are planetary nebula, how they got their name, how to observe them, and then, again, some of the historical and modern astronomers and their catalogs and some examples from their catalogs. And then we'll wrap up the presentation for the evening. So let's get started. What are planetary nebula? Well, planetary nebula are clouds of interstellar matter, thin shells of ionized gas and dust. They mark where a star is slowly dying. These nebula come in a wide variety of shapes and appearances. The central star that creates a planetary nebula is an advanced state of stellar evolution at or just beyond the end of its nuclear life cycle. When a star similar in size to our sun has used up all its central nuclear fuel, it first expands into a red giant star. But eventually the force of gravity causes it to contract. And during that process, it ejects a significant portion of its mass into a gaseous shell. Then ultraviolet radiation and light from the dying star energizes that shell of expanding gas, causing it to appear as a brightly colored planetary nebula. Now, planetaries are usually classified into three main types: spherical, elliptical, and bipolar. Now, some of these shapes are due to our line of sight angle and how the object is oriented to us, but also magnetic fields, stellar winds, and interactions with other nearby stars can produce a wide variety of shells. Most planetary nebula are just a few light years or less in diameter and last only a few tens of thousands of years. On cosmic timescales, these nebula undergo rapid changes so that those we observe are all fairly young objects. Over a period of time, the central star will cool down to a white dwarf star, and then the nebula will eventually fade from view. So again, these are very transient objects in astronomical terms. Well, how did planetaries get their name? Why do we call them that? Well, a lot of amateurs mistakenly credit Charles Messier for naming these types of deep sky objects, but that's not correct. Messier in 1764 did discover what would become the first planetary nebula, M27, the Dumbbell Nebula in the constellation of Vulpecula. And he listed it in his catalog of nebulous objects for comet hunters to avoid. Messier, with the help from fellow French astronomer and comet hunter Pierre Macon, went on to add 3 more of these objects to his catalog. And you know him as M57, M76, and M97. But he never described them as resembling planets. It wasn't until nearly 20 years later, and by another amateur astronomer at the time, that these types of objects were begun to be described as planetary nebula. In 1782, William Herschel, the discovery of the planet Uranus a year earlier, first used the term planet in his description of these objects. Quote, "These bodies appear to have a disk that is rather like a planet, that is to say, of equal brightness all round, round or somewhat oval, and about as well defined in outline as the disk of the planets," end quote. Now, while it's possible that Herschel had read a previous description of M57, it could very well be that Herschel had planets on his mind from his discovery of Uranus, as he was always keeping his eye out for finding additional solar system members. He found one new planet, why not find another one? So Herschel went on to use the term planetary in his publications of these objects whose characteristics are a well-defined round or oval shape with equal brightness across the disk. So the credit for popularizing the term planetary nebula goes to William Herschel. So how do we observe planetary nebula? Well, planetary nebula can be found scattered throughout all 4 seasons of the night sky. There are currently over 3,000 planetary nebula that's been identified, and the number increases every day. Most of these nebula that we can visually observe are located within the spiral arms of our own home galaxy. They can be found all along the glowing band of light that we call the Milky Way. And on the slide here, that's the blue, highlighted area. Unlike the irregular shaped glow of diffuse emission nebula, planetary nebula do live up to their name in that they are generally circular shaped disks. And again, using your imagination a little bit, somewhat resembles a planet. Some are evenly bright or illuminated across their disk, while others have a dark central region giving them a ring shape. And in some planetary nebulas, the central star that created the nebula can still be seen. Some good examples of planetary nebula with prominent central stars that are easily visible are NGC 40 in Cepheus, my favorite planetary, NGC 1514 in Taurus, 6826 in Cygnus, NGC 2392 in Gemini, and of course M27 in Vulpecula. Visually, if the planetary nebula's surface brightness is high enough and you have a large enough telescope, you may be able to see color in the planetary nebula. While most of the dimmer planetary nebula will have a grayish color like all the other nebula, the brighter planetaries may show variations of green and blue. Easiest to see colors in are, of course, M27, the Dumbbell Nebula in Vulpecula, M57, the Ring in Lyra, NGC 7662, the Blue Snowball in Andromeda, and NGC 6905, the Blue Flash in Delphinius. Those last two kind of give you an idea of what color to expect. Imagers will be able to pick up planetaries that have a reddish coloration in them, such as NGC 6781 Aquila, and of course the previous mentioned M27 and M57. Just about any planetary nebula. Now, these collars are from double and triple ionized oxygen and hydrogen caused by the intense UV radiation of the central star. When these atoms drop back down to a less excited state, they emit either a greenish or a reddish light, depending on the wavelength. To see collars in planetary nebula, you want to look directly at them. You don't want to use averted vision. That's because your eye's collar receptor cones are located at the center of your eye and not on the sides. So again, you want to look directly at the planetary nebula. In fact, I know some planetary nebula observers will actually take a dim white light and briefly flash their observing eye to activate the cones, and then quickly look through the telescope and attempt to see the coloration of the nebula. I don't know if I recommend that or not. To me, it seems like that would ruin your night vision for other things, but some people do that. Now, the majority of planetary nebula, though, are stellar in appearance, especially the Minkowskis, or exceedingly faint like the Abells, needing a specialized line filter such as oxygen 3 filter, or maybe even a spectroscope to be able to even identify them. Other narrowband filters such as Lumicon's UHC, Ryan's Ultrablock, Optolong's L-Enhance will help to visually enhance viewing planetary nebula. Also, general broadband light pollution filters that you can also get from Orion and other dealers will help, but not as much as the narrowband filters will. Now, while planetary nebula can be classified into the three generic types I mentioned, spherical, elliptical, and bipolar, there is a more detailed classification system created by Boris Vorontsov-Velyaminov in 1934 that is still in use today. It's denoted as the VV system. Of course, it runs through classes 1 through 6. Class 1, stellar image. It's star-like. It's hard to identify. I usually don't go after these myself, but again, smooth disk, irregular disk, ring or annular structure. Depending on the complexity of the shell structure, some planetaries are characterized by multiple combinations of this classification system. For example, M57, the ring nebula, is a class 4 and class 2 ring and disk. These classes will give you a good idea of what to expect from the nebula. Also, a good rule of thumb to keep in mind is that any planetary nebula that starts with an NGC number are generally observable extended objects with disk or shell structures that you can see visually. While most of the planetary nebula that have an IC number are stellar objects, or they have very small diameter disk, it makes them very difficult to distinguish from field stars. So, ingredients to successfully observe planetary nebula. In general, for visual observers, it's best to hunt planetaries starting off with a low-power, wide-field eyepiece to identify your target area. Once the planetary is centered, then you can switch to a higher magnification and use your filters to try to bring out details in the nebulous shells along with the central star. Then you might want to try using an even higher magnification, such as a 6 millimeter, or pull out that 4 millimeter eyepiece. And then you throw Barlow in there. You want to crank up your magnification as high as you possibly can, because generally planetary nebulas can handle high magnification. Now, Messier's 4 planetaries, with the exception of M97, are high surface brightness objects, and they're easily visible in most telescopes, even under suburban skies. The 20 planetary nebula from the Herschel catalog are also generally visible in medium-sized telescopes, though some will require larger reflectors and also maybe a dark country sky. But the planetaries listed in the Abell catalog are generally very old, extended, and faint, and it makes these objects very challenging to observe. The Minkowski planetary nebula are even more difficult, most appearing star-like and, of course, embedded in crowded Milky Way star fields, and they show little to no disk nebulosity. So for these guys, you're going to need maybe a 17-inch or 20-inch or larger type telescope, or maybe some type of imaging rigs to pull these in. Observing guides. there are a number of good planetary nebula-related observing guides available to us amateur astronomers. Here's a couple of my favorites. The Night Sky Observer's Guide, of course, Volume 4, Glories of the Milky Way by George Keppel. The fourth one here is a series of handbooks written by George Keppel and Glenn Sanner. Each chapter covers a specific constellation with finder charts, sketches, images, and visual descriptions of the various deep sky objects. New Volume 4 focuses specifically on constellations and their objects that lie along the path of the Milky Way. Each constellation chapter lists all the planetary nebula in a very convenient format within the book. So you just flip to that section and there's all the planetaries in that particular constellation with, again, visual descriptions or sketches or images of them. Another good handbook to have, though somewhat dated, is the Webb Society's Deep Sky Observers Handbook series, Volume 2, Planetary and Gaseous Nebula. Volume 2 lists a number of bright planetary nebula visible to small and medium-sized telescopes. The book lists a total of 80 planetary nebula with detailed descriptions and sketches, though the sketches didn't come out very well in the printing process, so they're not the best, but they'll give you at least a rough idea of what to expect. And of course, on the internet, there's a lot of good sites that you can visit. West Coast amateur astronomer Alvin Huey has a couple of great observing handbooks on his website, faintfuzzies.com. The first one is called Planetary Nebula and Supernova Remnants, which lists over 300 planetaries with finder charts and DSS images. It's a mixture of easy and hard to find, so it's useful to both beginners and intermediate amateurs. Alvin also has another handbook called the Abell Planetary Observer's Guide, and this handbook is for the more advanced amateur astronomer looking for a challenging visual or imaging observing project. Both handbooks contain finder charts, DSS, digital sky survey images, visual IP sketches, and descriptions made with a 22 or 30-inch telescope that Alvin uses. And I believe the first one there, Planetary Nebula and Supernova Remnants, is a free download. I think Alvin still charges for the Abell Planetary download. But what's nice about them is they're PDF format, so you can just save them on your device, or you can actually print them off if you have a nice printer, or you can take them to Kinko's or Office Supply Store or whatever, and actually have them print it and bind it. There's also another good internet resource called the Brightest Planetary Nebula Observing Atlas by Massimo Jetchen. It's again a downloadable PDF list of 35 best planetaries across the sky, many that have a high surface brightness observable with a small telescope from suburban locations. It comes in either a black or white version PDF, includes finder charts, object info, and a sketch made by the author. Again, another good one to download to your laptop or cell phone just to have with you, or also you can just print it out. So far we've covered what are planetary nebula, how they got named as such, and general tips on how to observe this type of deep sky object. But who are these people that I've mentioned along the way? Messier, Herschel, Minkowski, and Abell. Let's spend some time digging a little bit deeper into the background of some of these historical and modern astronomers associated with catalogs of planetary nebula. First up, Charles Messier. In July of 1764, while out comet hunting, Charles Messier ran across a bright nebula that would become the 27th object in his list to avoid while comet hunting. Messier referred to M27 as, quote, a nebula without a star. It appears of oval shape, end quote. That's all Messier had to say about it. This was, though, to become the first planetary nebula to be discovered, though it took another 20 years for it to actually be classified as one. Well, who was Charles Messier? The 18th century French astronomer Charles Messier is best known for his catalog of nebula and star clusters, first published in 1771. This list of eventually 110 deep sky objects is known to today's astronomers as the Messier catalog. As an astronomer, Messier's primary job was to hunt for comets. And during his comet searches, he kept running into these diffuse objects that would frustrate him. He would waste hours tracking them, or maybe even the entire evening tracking them, only to realize they weren't moving. They were permanent stationary objects. So he began a list to help comet hunters like himself to avoid these false comets. Messier worked as an astronomer again for the French Navy. His observatory was located within the city of Paris at an old hotel that was originally a medieval townhouse built in 1334. The observatory was built on top of a tower and was a wooden structure with large side windows that could be opened. Inside was kept the portable observatory telescopes that could be positioned to point out whichever window Messier preferred to look out. So Messier didn't have a permanently mounted observatory telescope. He just used these little portable guys and went around to whichever window that he wanted to look in that direction. For the majority of his observing work, Charles Messier used a small portable 4-inch refractor. Now, over the course of his lifetime, Charles Messier did discover 21 new comets, but it is his list of fixed diffuse objects to avoid while comet hunting, his catalog of nebula and star clusters that today's modern amateur astronomer seeks out as the bright showcase galaxies, nebula, and star clusters of the night sky. This is what Charles Messier, the ferret of comets, as he was known, is renowned for in the 21st century. So let's run through some examples of Messier's planetary nebula. Of course, first off, M27, known as the Dumbbell Nebula, also later called the Hourglass by John Herschel. It's located in the summer constellation of Vulpecula the Fox, and right about where I have it circled there, you'll see it on your screen. It was again discovered in 1764. It was the first planetary nebula ever discovered, and it's one of the brightest, most impressive, easily visible in binoculars. M27 is about 1,360 light years distant from us. It's estimated to be close to 14,600 years old, and it's about 3 light years overall in size. On summer evenings, it is well placed, almost directly overhead, and it can be naked eye from a dark sky country location. Due to its high surface brightness, though, M27 can even be observable through a small telescope or binoculars during full moon. Its central white dwarf star shines at a magnitude 12.9, and it's fairly easily visible at the center of the dumbbell-shaped nebula in small telescopes. Distinct structural features can be observed within M27, including bright, sharply defined arcs coming off of either end of the dumbbell shape, along with striations between the main arcs and the center of the nebula. UHC and O3 filters will definitely enhance the contrast of the internal features of this nebula, and it's well worth using them on it. M57, located in the summer constellation of Lyra the Lyre, or HARP. The Ring Nebula, as it's known, is the second planetary nebula discovered by Charles Messier in 1779, almost 15 years after the first one. It's easy to locate and can be observed with small telescopes, even in suburban skies, because it does have a high surface brightness to it. It's about 2,300 light years distant, about 6,000 years old, estimated to have a diameter of about maybe half a light year, and they calculate that it's expanding at 12 miles per second. With its high surface brightness, the ring is one of the best celestial showpieces of the summer sky. While the nebula itself is easy to observe, the central star at magnitude 15.4 can be difficult to glimpse in small telescopes. But interestingly, 3D modeling of the structure of M57 shows that it is actually very similar in shape to M27. The differences are in a matter of our viewing angle perspective. For the ring, we're kind of looking down the axis of one of its ends, whereas for M27, we're kind of looking at it broadside, straight on. So just interesting little fact there. M76, located in the fall constellation of Perseus the Hero, the Little Dumbbell Nebula, as it's known as, was discovered in 1780 by Messier's observing partner, Pierre Macon. about 2,500 light years distant, also about 6,000 years old, about 1.5 light years in size. Now, before it was determined that M76 was actually a planetary nebula, which didn't happen until 1918, not that long ago, it was once considered to be two separate emission nebula. It was given two NGC numbers, 650 and 651. Visually, it's not too difficult to find, and it does resemble its larger namesake in medium-sized telescopes. And then finally, the last Messier planetary nebula is M97, located in the circumpolar constellation of Ursa Major, the Great Bear, known as the Owl Nebula. The last planetary nebula on Messier's non-comet list was discovered in 1781 by Pierre Macon. The Owl Nebula got its name based on a sketch made in 1848 by the 3rd Earl of Ross, William Parsons, using his 72-inch reflector. It's about 2,000 light years distance, about 8,000 years old. M97 is located near the bright Dipper Bull star Merak, Beta Ursus Majoris, which normally you would think of would make the planetary easy to find. But the nebula is fairly faint and does require a medium-sized telescope in a dark sky to be able to see visually. So like some deep sky objects, they can be harder to find than what you would think. Let's move on and talk a little bit about William Herschel. In William Herschel's Deep Sky Catalog, one of his major classification system categories was Class 4, which he called Planetary Nebula. There are a total of 77 objects listed in this category, but interestingly, only 20 of these objects are true planetary nebula. Herschel was known for dropping objects that he wasn't quite sure on how to classify into this category. It was his catch-all, his junk drawer, so to speak, of where to stick things that he couldn't figure out what they were. Well, after the Messier list, the Herschels are the next most observable deep sky objects. Most amateur astronomers know them by their NGC number, but they started out as a list created by British astronomer William Herschel and his sister Caroline Herschel. For his discovery of the planet Uranus, King George III of England in 1782 knighted William Herschel as the king's personal astronomer, and he gave William this annual pension. This allowed William to retire from his profession as a music teacher and devote himself full-time to astronomy. So who says amateur astronomy doesn't pay? Well, using his new wealth, the Herschels relocated to a small village in the countryside within a mile of Windsor Castle to be near the king, and he built a new permanently installed giant telescope called the 20-foot reflector, which had an 18.5-inch speculum metal mirror mounted inside of it. From 1782 to 1790, using the 20-foot reflector, the Herschels conducted systematic surveys of the night sky in search of deep sky objects and discovered close to 2,500 of them. In 1834, William Herschel's son, John, restored the 20-foot telescope and took it to Cape Town, South Africa, where he added another 1,700 plus entries to their list. Eventually, all the Herschel objects, along with the discoveries of other astronomers from the 18th century, were combined and published in 1888 as the New General Catalog, abbreviated NGC. This is where the NGC came from, based off of all the Herschels. So William Herschel was one of the most notable observers in the history of astronomy, and he's often referred to today as the father of observational astronomy. And like most stargazers do today, all his observations were made outside in the open, exposed to the elements, and not from inside an observatory building. So let's talk a little bit about some of his examples. We won't do all 20, we'll just do a few of my favorite. And of course, my favorite NGC number is that of NGC 40, located in the fall constellation of Cepheus the King. The Bowtie Nebula was discovered by Herschel in 1788. It's about 3,500 light years distant and about 1 light year in diameter. Visually, NGC 40 is a bright bluish-green oval-shaped 10.7 magnitude planetary nebula, in which small to medium-sized telescopes will show the 11th magnitude central star, and they'll also show bright structural arcs on either side of the star. In images, NGC 40 also shows a bright red color from the ionized hydrogen. Then there's NGC 6894, located in the summer constellation of Cygnus. It was discovered by Herschel in 1784. This 12th magnitude dim ring-shaped planetary is located about 5,000 light years from us, has a dim central star of 17.6 magnitude. It's getting down there. It's best visible in medium to large telescopes from a dark country location. And again, it does have a nice ring shape. It was only a little bit brighter. It'd be another ring nebula that we could all enjoy. NGC 6826, also in the summer constellation of Cygnus, nicknamed the Blinking Planetary, was discovered by Herschel in 1793. This 10th magnitude planetary is located about 3,200 light years from us, has a bright central star of magnitude 8.9, making it an easy target for small telescopes. Visually, when observing the bright central star directly, the nebula tends to vanish. But then when you use your averted vision, the nebula blinks back into view. This is why it's nicknamed the Blinking Planetary. So this is one of those instances where you don't want to look at it directly. You kind of want to look off to either side to get the shell to appear. NGC 6905, located in the summer constellation of Delphinius, discovered by Herschel in 1784. The Blue Flash Nebula is an oval-shaped 11th magnitude planetary with a 13.5 magnitude central star at a distance to us of about 4,200 light years. Visually, the planetary nebula is fairly bright in small to medium telescopes, and it does show a bluish color in the larger scopes, again, why it's called the Blue Flash Nebula. And finally, the last Herschel we'll talk about tonight is NGC 6445, located in the summer constellation of Sagittarius, discovered by Herschel in 1786. Nicknamed the Box Nebula, NGC 6445, it's about 3,200 light years distance, and it has a diameter of almost 4 light years, kind of a larger nebula. Visually, it's a small, faint nebula with a rectangular disk. It's really best suited for the larger aperture telescopes. It has a very, very faint 19th magnitude central star that's going to be visible only in large 24 inches or greater telescopes, or maybe in an imaging kit, you can pick it up. German-American astrophysicist Rudolf Minkowski was born on May 28, 1885 in Strasbourg, Germany. In 1913, Minkowski enrolled at the University of Breslau to study physics, but was drafted into the German army in 1914 and served through the end of World War I in 1918. Excuse me. Afterwards, he returned to the university where he earned his PhD in 1921. In 1922, he went to work for the University of Hamburg, first as an atomic physicist and then later as an astronomer. In 1935, Minkowski accepted a research position at Mount Wilson Observatory and immigrated to the United States. Minkowski is best known for his Mount Wilson research work on supernova remnants with astrophysicist Walter Baade, in which the two of them devised the spectral grouping of type 1 and type 2, which is still used today to classify these violet explosions, and also as a tool in determining cosmological distances to galaxies. Excuse me. But in the late 1940s, Minkowski published 3 versions of a paper titled New Emission Nebula, where he listed over 200 planetary nebula that he had studied for their spectra, galactic distribution, and motion. In his 3 separate papers, Minkowski didn't formally label or number his entries. He just referred to them by their right ascension and declination. But later, when they were collected into a catalog, they were given designations based on which paper they were first referenced in. An example would be of a Minkowski catalog entry would be M2-9, the Butterfly Nebula in the constellation of Ophiuchus. It's the 9th object in his second paper. So that's how that strange number system came about. So most of the Minkowski planetary nebula are very faint, very small, star-like, less than 10 arc seconds in diameter. Again, less than 13th magnitude. and they're very difficult visual observations. The best way to visually confirm that you've found one is to use your UHC or oxygen 3 or narrowband filter to rapidly pass it back and forth of your eye in the eyepiece to causing the planetary nebula to blink in brightness from the other stars in the field of view. The stars will dim, the planetary nebula will remain. Good technique to use to blink it. So some examples of Minkowski's, some of my favorites. M1-74, located in the constellation of Sagitta. I'm sorry, actually in the constellation of Aquila. It's a magnitude 12.9, again, a star-like planetary. There's also M1-59, located in the summer constellation of Scutum, sort of down there in the middle of the brighter Milky Way portions, which makes it kind of difficult. It's a magnitude 13.3, again, another star-like planetary, difficult to separate out from all the field stars that are in the field of view. M1-64, located in the summer constellation of Lyra. Actually, this is sort of one of the more easier ones to find because it's located in sort of a sparser section of the Milky Way and right in the middle of the rectangular asterism shape of Lyra. So it gives you a good idea how to find it. This guy is also magnitude 13.3, but it does show a small disk. So this one is kind of fun to look for. It's very near a faint star too. And finally, the last Minkowski we'll talk about tonight, M2-55, located in the fall constellation of Cephus. It's a magnitude 14.3. This one also has a fairly good size extended disk. And it makes it worthwhile looking for, but again, it is very faint. You do need a large telescope, I would say at least 15 inches in size or bigger, and a dark sky location in order to see this. George Abell. American astrophysicist George Abell was born March 27, 1927 in Los Angeles, California. As a young boy growing up, George's father would take him to various LA museums, including the Griffith Observatory and Planetarium. This led to George developing an interest in science and astronomy, which he excelled at in school. After graduating from high school in 1945, George enrolled at Caltech, where he studied physics and astronomy. Abell graduated in 1951 from the California Institute of Technology with a BS in astronomy. He continued on for his master's in 1952, got his doctorate in 1957. Abell's first professional job was as a Caltech astronomer working on the National Geographic Society's Palomar Observatory Sky Survey, created using the Palomar 48-inch Schmidt telescope. George's primary research was reviewing the POSS survey photographic plates looking for the formation of galaxy clusters. But while searching through the plates for faint galaxies, he ran across a number of unreported planetary nebula. From the new data collected on the plates, Abell compiled a list of 86 very old and very faint planetary nebula, which he published in 1966. Abell's catalog is recognized today as an excellent compilation of faint, challenging planetaries for the visual observer with access to larger telescopes and dark skies, and to imagers using either video astronomy or the more traditional astrophotography cameras. Over half of the Abell planetary nebula have central stars of magnitude 17 or greater, or fainter, I should say. So incredibly dim shells and even dimmer central stars. Interestingly, back in the early 1980s, before the large Dobsonian revolution took hold, George Abell was once asked by an amateur astronomer about observing his planetaries. Well, being more of a theorist than an observational astronomer, Abell replied that he doubted that any would ever be visually observable and that maybe it might be possible to photograph very few of the brighter ones. Well, today we know that numerous amateur astronomers armed with either large reflectors of 25 inches or greater using state-of-the-art imaging telescopes and cameras are routinely observing and imaging all of his planetary nebulas. So they are quite doable. Generally, it's best, though, to save hunting for Abell planetaries for trips to dark sky locations and on nights of excellent transparency. Visual observers must be completely dark adapted and avoid all lights during observing. You definitely want to use your averted vision on these guys. While some Abells can be observed using small telescopes, most of these objects will require larger telescopes, at least 20 inches, maybe 25 or even bigger to see, or again, some type of imaging kit. So let's talk a little bit about some of my favorite Abell examples. First one, Abell 4, located in the fall constellation of Perseus. It's a magnitude 16.7 planetary, and it's also kind of fun to go after because it has a little friend next to it, galaxy CG 539-91. And you'll notice as we look through these images of mine of Abell planetary nebulae that they're all 3-minute exposures, some using a filter, some not. So just again, give you an idea of how faint these are. Another one of my favorite Abells, Abell 10, located in the winter constellation of Orion, sort of up there on his shoulder. This one is a magnitude 15.2 shell. Again, it does have a nice large shape once you find it, but it is very, very faint. Abell 50, also this one has an NGC number because it's a little bit brighter than the average Abell. It's NGC 6742, located in the constellation of Draco. This one's magnitude 13.4, and again has a nice disk to it. And finally, Abell 81, which has an IC number, IC 1454, located in the fall constellation of Cepheus. And it's actually, depending on your location, you could probably consider it to be circumpolar, visible throughout the year. This one is magnitude 14.8, and it has a ring shape to it. Again, if it was only brighter, it'd make another companion to the Ring Nebula. Okay, let's try to wrap up this presentation and see if anyone has questions. So today, I've introduced you to a class of colorful, luminescent, wispy shells of deep sky objects and some of their catalogs. We've learned a little bit about the historical and modern individuals behind each catalog, and we've looked at professional and color photographs along with amateur sketches and video capture examples of various members of each catalog. Hopefully this little presentation has inspired you to search out and explore these very rewarding celestial objects. So I encourage everyone to get out tonight. It's a clear night, though it's cold, but try your hand at finding and observing the ghostly disk of these elusive deep sky objects. The Planetary Nebula of Charles Messier, William Herschel, Rudolf Minkowski, and George Abell. Now, if you'd like to read the full version of this presentation, I actually have a little research paper on my website, and you can go to it by using the handout I listed there. At the bottom of it, it has my website, stellar-journeys.org. And once you go there, if you look over on the table of contents on the left-hand side, you just scroll down through it. You'll get to a PDF download page. Click on that. You'll find this talk a little bit more expanded format. And you'll find some other presentations in the past, the Herschels, Messier, Barnard, and so on. If you like to read about Planetary Nebula, in addition to the guidebooks I mentioned earlier, there's a number of other great books. Messier's Nebula and Star Clusters by Kenneth Lynn Jones, The Complete Guide to the Herschel Objects by Mark Braxton, and of course the Night Sky Observer Guides book. Can't go wrong with those. Magazines, there's too many here to mention, but it seems like about every 2 or 3 months, one of the major magazines, Sky and Telescope, Astronomy, Sky at Night, you name it, comes out with a great observing article on planetary nebulas for whatever season that they're talking about. So I recommend that you save those issues, cut them out, put them in a folder, and you can pull them out next time you're out observing. Internet resources, if you want to look for some great images of planetary nebula, National Optical Astronomy Observatory, NOAO, has a great site. You can find all kinds of great images. And of course, Google, Wikipedia are your friend. And of course, some of the beautiful images I showed you here a little while ago. All of these came, most of them from NOAO. Most of these had the astrophotographer Adam Block had his finger involved in them. So that does conclude my presentation. At this point, I will be happy to take any questions you might have on Planetary Nebula, Charles Messier, William Herschel, or anything else under the sky that you might want to talk about.
I put a link to Larry's site at the bottom there. I know you put it up there earlier, Larry, but I put it down at the bottom in case nobody scrolls all the way up to see it. So, is your presentation available on your site as well?
Yes, it is. Actually, let's see here. I can show that.
Yeah. So all those book links and some of the suggested Larry's favorite Planetary Nebula are listed on there too. So you want to try to catch up with some of those. Those are listed on there. But Larry, I have a quiz for you. There's actually another planetary that Messier inadvertently found. I don't think he knew that he found it because it's in another one of his objects.
Oh, really?
Did you know? Yeah.
A true planetary nebula that he found.
Yeah.
Oh, okay.
It's a bit of a trick question. In Messier 46, if you look at Messier 46, it's actually a globular cluster, and there's a planetary nebula between us and that nebula or that cluster, and there's a planetary nebula in the foreground. Actually, I could share it. Let me try that.
Yeah, here. Let me stop sharing and give it back to you.
I'll take it.
Oh, I know what you mean. You're right. You're right. See, I don't think he actually ever saw that.
Yeah, that's why it's kind of a tricky answer to the question.
Yes, there it is.
So there's a planetary nebula here, right at the edge of M46.
Yeah, that's a twofer. It's a beautiful star cluster, and it has that little surprise planetary nebula.
Yes,
and it's currently visible tonight if you get out.
Yes. Just a trick one.
So again, planetary nebula, they're one of my favorite deep sky objects, and there are some nice ones visible in small to medium-sized telescopes. And when you do find it, don't be afraid of really running up the magnification. I mean, I'm talking hundreds of power here on these guys.
Amazing. So I have a question on the Night Sky Observer's Guide. I didn't know there was a volume 4. When did that come out?
Oh yeah, that came out. When was that? Was that 2019? I think. I knew he'd been working on it for a number of years. George is actually a member of my astronomy club, Kiski Astronomers, and he again that book focuses just on the constellations in the Milky Way, so there's no galaxies in it, and he goes into a lot more detail than he did in the first three. He lists more nebula, more clusters, and so on, and also he updated the images that he's taken. George used to be a big prolific sketcher, but unfortunately, almost 20 years ago, I guess at this star party, when I was getting into video astronomy, I accidentally spoiled him and turned him into an astrophotographer.
So much for the sketching.
Yeah, well, he still does sketches, but man, he just he is a very talented individual.
I didn't realize he was part of your group there. I think I met him at the Black Forest Star Party a number of years ago.
Yeah, he likes to come to the various star parties, especially Black Forest, and sells his book. But he's lived, oh my gosh, when was that? It's been at least 15 years or more since he moved out to Arizona.
Okay. Interesting. Any other questions for Larry? Go ahead.
No, just I got a compliment. By the way, that's a fantastic presentation. Matter of fact, Mark, I thought it would make a great prelude or pre-work to Messier marathons for those that are uninitiated.
So that's what we can do next weekend. Now, we can't exactly complete it because it's April, but we also have the opportunity for potentially warmer weather than we had.
But it's a start.
April 10th, we're going to have an open house during the day, but at dusk, you want to come to try a Messier Marathon Part 2, if you would, on a Saturday night. I'm actually going to be doing a virtual one because I went out there a week or so ago. Well, whatever it was. I don't remember exactly when. 2 weeks ago now, and did what I could get at the last new moon, or there was actually a first quarter moon, but because it was late enough, the moon didn't bother me. I went out after midnight to catch the parts that I got clouded out with at the end. So there'll be a virtual finish to the Messier Marathon next Friday that we'll do right here at this same bat channel at 7:30.
Yeah. And Mark, you should be able to pull in all 4 of Messier's planetaries.
Yep.
That would be perfect.
Yes.
All right. Anyone else have a question?
So have you, I had a question for you personally, Larry. Have you worked through some of these catalogs, the Minkowski and the Abell catalog?
Actually, I have started a project on the Abels and using my my old Stellacam video camera. I've kind of recently put that aside. About a year or so back, I got one of the ZWO cameras, color cameras, and it's like a whole new world, and so I've been enmeshed in that. And actually, I've been trying to decide how I want to pick up the Abels again and start doing it. If I want to continue using the video astronomy camera that I started with, or do I want to start over with the other camera, or just continue? I can't decide how I want to do it. So, but in the meantime, I've been working actually on the Sharpless catalog, the HD star forming regions, and there'll be a talk on that probably in another year or so.
All right, we got your number.
Yeah. Yeah, actually, there's quite a few on my website there. I actually just I have 2 that you haven't seen at Cherry Springs yet. One on the local group of galaxies, which was going to be last year's talk till we got canned. And then also, I just back in the spring wrote another one on Galileo, the first visual astronomer. And actually, I'm in the process of finishing up another one on. It's called Comet Tales, the myth and science of comets and how to observe them.
Oh, that sounds cool.
Yeah, that one's not ready for prime time yet. So
a little spin on words, Comet Tales. Good.
Yeah.
Bill says, thanks, Larry. Very enjoyable and informative talk. Hope to see you at Cherry Springs State Park in the near future. Good luck to them Stillers. He spelled it correctly, Stillers. That's how you pronounce it down there, Stillers.
Steelers, yep.
Even though I've been there long enough to go to Bill's supporter. That's funny. Thanks, Bill. Have you heard anything about Black Forest yet? It looks like by the calendar, it's probably going to be Labor Day if it happens, doesn't it?
That's my guess, too. I haven't heard anything official, but, I just have my fingers crossed that by then things will be settled down, that they'll be able to hold it, and
yeah.
I had hopes for Cherry Springs, but I had a feeling that was going to be too early, and unfortunately they had to cancel. So
that's too bad. That's too bad. It's too early. It sounds like things are going to open up quite a bit by the end of the summer, but it's still all conjecture at this point.
Right. Our club, we put on a little convention called Astro Blast there at our observatory that we have near Clarion. And it's scheduled for mid-August, so we got our fingers crossed that we're going to be able to get it in. But I think at this point it's sort of a 50-50 right now. But we'll see how it goes over the next couple of months.
That's kind of where we are right now with our Rochester Art Fest. Although it's looking promising. We'll see.
Mm-hmm.
We'll see.
Yeah, I have a feeling we may require everybody to be vaccinated. In order to attend. We're not sure. We're kicking around that idea. But we'll see,
If we're in New York, we're probably going to be required to do something like that. So, we'll see.
Essentially, vaccine passports.
Yep.
Yes.
Right, Marty.
I think that's going to be a thing. Well, anyways, again, thank you very much. I appreciate the opportunity to do this. These are fun. I enjoy sharing astronomy by doing this. And usually the presentations that I put together, I try to base them off of an observing project I'm doing, to kind of tie in what other amateur astronomers can see, And then also I kind of like to work in historical information, like like tonight of Charles Messier and William Herschel and that.
Yeah, it's fascinating how what these guys have done, and then not to be outdone, how these guys get deeper and deeper into the sky. It's just amazing what Abell's found more recently that's out there. How big is the Abell catalog? Do you know?
There are not that many. I think there's 86. I think.
Okay.
Yeah. Another project I'm working on, similar, is the ARP galaxies. There's 300 and some of those guys, but they're also there's some nice bright ones, Messier, but there's also a lot of faint stuff. But it's a fun project.
That's great. That's great.
Too many
Well, my
objects.
compliments to you. I think you did great.
Really appreciate it, Larry. Thanks for such a great talk. Really do appreciate it.
You're welcome.
Folks, if you want to get on and chat a little bit, feel free to turn on your camera, turn on your mic if you want to chat for a few minutes. It's hard for just me and Larry to fill all this space. We could do it though. Mary enjoyed the talk. That's great. Mary's been to Black Forest a number of times. We usually see, and so has Nick, two regular Black Forest people. There's probably in this group, I want to say there's probably a dozen. It's more than a dozen of us that typically go down. And we're usually parked over at the west end of the field along the fence, and that just past that Dobb Valley there.
Yeah. The group I hang out with, the Kiski astronomers, usually we park there. What is it? Orion Way. It was the one where the roll-off roof used to be.
Yes, I know where you're talking. Yeah, it's not there anymore, but I know what you're talking about.
Yeah, things that aren't there anymore. Yeah, so we kind of park in that area. It's far enough from the gate. We're not bothered too much by the light, but still within good walking distance of the facilities.
There you go. Mary says the west end where there is no real bathroom. No, it's a big latrine, but I guess in a pinch, trees. Orion Way. Is it Orion Way you're referring to, Bill, when you say trees? Yeah, you are close to the east side of the field there. So the problem is when Orion's coming up, everybody on the west side can see it, but everybody on the east side can't see it yet. At 5 o'clock in the morning.
Yeah. There's that one little sweet spot, that gap there. I know a lot of people try to get in that little wedge there, but it's
a little wedge.
You got to get there early. I mean,
it's funny how the tree line you define where you want to be, right in that spot there. Yes.
Oh yeah. That anymore, it's like it used to be you could come on a Wednesday to that star party, or Cherry Springs or Black Forest, and not worry about getting a nice spot, but that started creeping. Now it's like we go up on Saturday or Sunday before and stay the entire week just to make sure we get our spots. It's
crazy. It's crazy, and there's bigger and bigger vehicles there now too.
Yeah. You know when it's really packed when you see people putting tents up next to the porta-johns. That's desperation there. But taking one for the team, I guess. Yeah. Those people the next year, they come early.
That's right. If it's really cold, it's not that bad. But if it's a warm one, you're going to notice those porta potties.
Oh yeah.
So how many people are going to come out for a Messier marathon next weekend? I'm going to try anyway. Should be fun. I don't know what the weather forecast is. I haven't looked around here. Mary says depends on the weather. I'm with you, Mary. I understand that. It's 29 degrees in Ionia right now. And next Saturday, it's supposed to be a high of 57 and a low of 41. But it looks cloudy, unfortunately. Now it's clearing up. We'll see. It's far enough away where we don't know, but it looks like it's not going to be ridiculously cold. So it could be worthwhile. So any other observers on there want to talk about observing at all? Let me see. Jeff says he grew up in Coudersport, about 10 miles from Cherry Springs. He remembers Cherry Springs before it became an astronomy destination. Used to be an airport there, right across the street. I think I started coming down just after it was decommissioned.
And Coudersport, that's the big city up there.
It is. It is. Yep, small planes only, Jeff says. Yep, there's a little small plane. That's gone. The airport's gone. That's now a public observing area, Jeff, if you haven't been down there in a while. So people who are not going to be staying overnight can go to that public observing area across the street in the former airport. It's nice because it's kind of flat there. You got a lot of visibility from side to side.
Yeah. You know, it's funny because some of my friends, we'll walk over there at night, and it's like, there's better horizons over there than there is in the observing field. It's like, if they could just flop the two, it would be better to be across the street. But
I'm sure somebody's going to come up with that down the line.
Yeah,
it'll mess everybody up.
Yeah, I mean the park has done a nice job over there. There's the outdoor planetarium, with the bench seats, and the Rangers put on a really nice show over there too, for the public. Again, flat horizons. We've walked over there in the past when we've known there's been like a rocket launch from Wallops Island. If you go over there, you can actually see the rocket if it's going up the East Coast.
Oh, really? That's kind of cool. So those of you listening that haven't been to Cherry Springs, I hope that maybe it's inspiring you to want to go down there. It is a dark sky site, so people are required to use red light. You can't use white light at night. It's very much astronomy geared and focused, so that people doing observing and imaging have a really nice sky to work with, and no white light interference. So even people with their RVs have red lights on and such. So it's very, very well done, and they do a good job of maintaining that.
Mm-hmm. And what's nice is, all the roads have gravel on it, and you can kind of see it at night after you're darkened out. And most of the field is fairly level. You can walk across the field without too much worry of breaking your leg.
Yeah, there's no holes in the ground. So yeah, it's.
There are a few places you want to watch. Especially if there's been a heavy rain there, you want to be careful because you might step in a big puddle in a couple places.
Yeah. There was, and Bill just mentioned it. I was just about to say that. He said we saw a launch or some effects thereof at a Black Forest Star Party a few years back. I think it might have been Bill. We saw a weather balloon pop, and there was like the gas from inside the balloon was illuminated by the sun. It was kind of weird looking, low on the horizon. I believe it was over in I think it was in the east. It was really interesting.
Yeah, I know. Like this was about 5 years or so ago. It was, again, we were over there watching a launch from Wallops. It was a 2-stager, and you could see the first stage just coming up over the trees, and it disappeared. And first we're thinking, well, is that really it or not? And then if you followed the arc of it, just a few seconds later, there went the second stage lighting up and heading on until it eventually did fade out of view.
So a confirmation stage.
Yeah. But for those of you who've never gone to Cherry Springs, though, you do want to be careful as far as food up there. You don't want to leave anything sitting out because Yogi will come visit you if you do.
Yes. I mean, there's a lot of people. They'll typically, if you have food out, they're going to try to find it. But if you're careful with your food, you should be fine. There's a lot of people who really don't like to bother with people, but don't give them a reason to come around.
Yeah. During the main conventions, when there's 100 or 200 people in the field, you don't have too much to worry about unless you get there early, and you're over near the edge of the field. Bears have been known to come in and grab someone's cooler and run, they will do that. So years ago, they used to have like up where we camped, over in the woods there was a family of albino skunks. And apparently they were hard of seeing. They had very poor eyesight, but they would come into the field, and even during the middle of the big convention, and they would be there walking around at night, and of course you would see them because they're white, but if they came by, you would stomp your feet on the ground. They would hear that, feel the vibration, and they would go in different directions. There was one night I was out observing. It was late, well after midnight, and my buddy next to me, I thought he'd gone to bed, but I heard this rustling noise inside his easy up tent. I thought, well, he's back out, so I went to pop over, and I went to go inside his tent there, and there it was, the skunk was in there trying to get into his cooler, so it's like now, were you there again, this was a few years back when the great horned owl attacked the blue herring nest?
Oh, I don't remember that.
Oh yeah, this was it was the spring. It was the Cherry Spring Star Party, and it was probably maybe about 4 years or so ago. And you've seen the blue herons, right? They come in and they would nest in that one grove of pine trees.
Right.
One evening, we were all out there again. I think it was like a Friday night of the Star Party. Hundreds of us on the field. We're all out there observing, and it's like well after midnight. And man, it sounded like someone was being murdered. And everybody just sort of walked out, was looking up from their telescopes and coming out from their imaging rings, like, what is going on? And you could tell where it was coming in that general direction. And the next day, we were talking to some people who actually camped down there, and they said what it was a great horned owl flew into that grove of trees and went after the nestlings in the blue herrings.
Wow.
And they actually found that, I guess their park rangers later that day went back and they found a dead one, on the ground. So that was just, but it was just, it was really eerie. It was just.
It could be a little startling, to say the least.
Yeah. More so than the coyotes.
Yes. Well, we get coyotes at our dark sky site all the time. We're kind of in the middle of nowhere, and in the distance, some nights you can hear a whole band of coyotes howling over their prey.
Yeah. At the last Black Forest, I guess 2019, you could hear to the north there was a pack. You could hear them howling, and then over to the east you heard a second path responding. It's like, wow.
I remember that. I do remember that. We could hear those guys.
Okay, yeah.
And I thought they moved, but they weren't moving.
They were two separate ones. You could tell. Yeah. That's a great place.
It's a fun place. Really enjoy it. So, yeah. Unfortunately, if the Black Forest Star Party's in Labor Day, it's tough for me to go. So I might pick another dark sky weekend to go, maybe the first weekend in October or something. Go down there.
Yeah. When you look at the calendar, it's either that weekend or, again, very late in September. And I don't think they like to go too late.
Yeah. If it was they can't do it in August because that weekend's reserved for the that wood cutters.
Yeah, Woodsman show. Well, I'm going to drop off for the night because it is clear out there. I'm going to put my heavy coat out and maybe venture outside and do a little planetary nebula hunting.
All right. Sounds good. Thanks, Larry. Appreciate your coming today.
Yeah. Again, thank you very much. I truly enjoyed it. And you guys have a great evening. I might drop in on you next Friday and just to see how your Messier marathon's going.
All right. I'll copy you on the invite. Make sure you get it. It's the same link. So if you just
same link. Yeah. I wrote it. Yeah, I got it. All right. Thanks a lot, everyone. Appreciate it. You have a good evening.
Thank you.
Larry.
Thank you.
Awesome. Love having Larry here. He's such an easy speaker. He makes things very understandable, very easy to talk to. Great guy. Of course, now somebody else has to talk besides me. Otherwise, this gets boring really fast.
Well, Mark, I'm going to drop offline because I got some radio astronomy work to do. That's why I was a little late at school doing a whole bunch of characterization of receivers. But I want to thank you for your efforts. I think he was a great speaker. I really enjoyed it.
Does a really nice job. We could thank Dave Bishop for getting him through here. So he's
thanks, Dave.
Yes, that was great speakers. I don't know if Dave's still on. He's still on. Yeah. So
Yeah,
thanks,
he's-
Marty. It's
All
clear
right,
out,
hey.
Marty. You don't want to do any radio astronomy tonight. It's clear. It's like a waste of
Are
time.
you kidding? My star's already set. What are you talking about?
That's awesome. Yep, it is a nice night. It's clear here. If you want to do some observing, it's a little cold. Like I said, it's 29 in I think it's 29 in Ionia right now. Yeah, going down to 23. My brother's out in Arizona. He's bragging. He doesn't intend to do this, but it's 90 degrees out there. Poor guy. All right. Well, here's what I'll do. I'll just promote the next couple things coming up. We've got a virtual Messier marathon. I've already done it. I taped it. I got to put the video stuff together, and we'll do that on Friday at 7:30. Same link as you got for tonight. I'll also send a reminder out for that. On Saturday, we have the open house, and if you want to go out to the site, there'll be people there to do observing, whether you do a Messier marathon or just do some observing. Right now, the weather doesn't look great, but we'll see what develops to do that observing. And then if you want to contribute or listen in or be part of the board meeting, we're meeting on Wednesday. It's a different link and a password. That's at 7 o'clock on Wednesday. If you're interested, shoot me an email. You can respond to the email that I sent earlier today or earlier this week. And I'm glad to respond with that information if you want to attend one of our board meetings next Wednesday. All right, with that, I'll bid you guys a good night and have a great weekend. Good to see everybody. Some of us. Have a good night, everyone.